So that's your piece of paper for notes. I don't have it on my thing because I'm just going to do it here. But it is graphing linear inequalities. What is it? Linear inequalities. And this really, ladies and gentlemen, is all you need to know. Basically, it is the same as linear equations with a small adjustment. And I'm going to start with the harder one, not the easier one. For example, this one. Look at problem number 2 on your little thingamabob here. Problem number 2 on your paper was y is less than or equal to 2x minus 3. If you were thinking about that as a linear equation, Parker-Gall, what form is it in? Y equals 2x minus 3. Standard or slope-intercept? Oh boy. See, this is where things went south.
Slope-intercept.
Did you say slope-intercept?
Yes.
It is. And how do you graph this line? This is where it crosses the y-axis, correct? Again, we're thinking in terms of linear equations. Crosses at -3. And the slope is 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So you get this line, right? Here's where we're going to pause, because this is where the wheels fall off for every other human being here. Okay, the difference between this is it isn't y equals 2x minus 3. Actually, it is. This part is y equals 2x 3. But this part says y is less than that. Y is less than that. And that's very important, because all the values that are smaller than that are what you want. So you have to think about it in terms of this. You think about the y-axis, where all of the values get smaller on the y-axis. See, right here's my y point. If I go this way, all my y numbers get bigger. That's not what I want. I want all the ones where it goes smaller. So this is your starting line, and anything underneath that, because that's where y gets smaller, gets shaded in. I should probably use a little shade thing. So this is actually what the graph of this looks like. You shade this whole thing in, because the answer to this is anything less than this line. And for some reason people struggle with that whole less than on the y-axis. They start thinking about x-axis or whatever. No, it's got to be y. You're thinking only of where we're at y is less than. Are you with me on that? Now, okay, before Evelyn asks her question here, if, ladies and gentlemen, if this equal sign wasn't here, if that equal sign isn't there, that means it still starts at that place, but it doesn't include that line. If there's no equal sign there, then you make this line a dashed line, which means it starts there but doesn't equal there. But it wasn't. It actually was an equal sign. So there. Now, Evelyn, your question. Did that answer it?
Yeah.
Thank you very much for it.
Not waiting.
So it's really a pretty simple thing. Let me do another harder one. Let's just do, well, let's do number 4. Y is less than negative. Y is less than negative 5/3 x, what? Minus something. Minus 1. And it's a pretty simple process here. Now again, noting that this doesn't have an equal sign, so it's going to be dashed. Here at -1 is your starting point. Goes up 5/3. Make sure you do negative. Up 1, up 2, up 3, up 4, up 5, over 1, over 2, over 3. It's negative, but it also is not equal, so when you do it, you have to do a dashed line. So far so good. And then it is y is less than. Y is less than. What side of that line am I going to shade? Your choice is right here going up or right here going down. The thing you look at is the y-axis. Here's the place. You're going to shade it above it or below it. If it's where the y is less than, you go down where the numbers get smaller for y. So this is the shaded part. Just talk wet, W-H-E-T, your appetite for tomorrow. We're going to do systems of equations, which means you graph more than one, and you're trying to figure out where they overlap. That should be exciting. Now, you obviously have a question about problem number 1, where x is greater than 5. There are some small exceptions here. Think about this. Since this doesn't have a y, we really don't think about y a whole lot. Where is x equal to 5? Right here, right? 1, 2, 3, 4, 5. If you look back in your notes, when we had x equals 5 or x whatever, that just means no matter what y is, x is always 5. So generally my line would have been this. That's where x is equal to 5. But since there's no equal sign under it, it has to be a dashed line. And only on this case do you not really care about the y-axis. On what side of that would you shade? On what side is x bigger than 5? This side or that? This or that? This or that? Right. All the numbers on x get bigger on that other side. On this other side, sorry. Oh, I don't want red. What color would be good?
Purple, green.
No, green is
White.
almost like illegible.
Green.
You can't see it because it's illegible.
And what was the last one? Oh, y is less than or equal to 0. That last problem there. Y is less than or equal to 0. Right? You're only concerned with y. Where does y equal 0? Right here. Right? And y is 0 through this hole. It's really the x-axis because that's where y is 0. And then I am going to shade either the top of that or the bottom of that, Grant, and you are going to tell me I'm going to shade top or bottom of that line. Where is y less than? On the bottom. So back down here. Sorry. Not a lot of numbers there. That don't seem so bad, do it? Tomorrow will be more fun, and then we'll get to quadratics. I'm not sure why this ended up in this section here, but it is there.